Hi everyone. Okay, so today we are going to talk about actually growth and decay equations. And what we've been doing so far, calculus-wise, is we've been creating the growth and decay process. Today we're going to take the equation and just solve it. No calculus involved. Now, with the growth and decay equation, you guys know that y is your ending value of whatever we're talking about, whether it be an isotope, bacteria, whatever. C is going to be our beginning balance. The K is going to be our growth rate. And when we talk about that growth rate, that means that if it is a positive value, that it's increasing. So it's growing like bacteria growing in a petri dish. If it's negative, it means it's decaying or decreasing. And that would be like something decaying in the woods. And the T is going to stand for time. Okay, so you're going to be given a bunch of problems in different format. So the first format is to complete a table. So this first piece of information here is just the name of whatever we're looking for. The name, even though it has numbers in it, we don't use. The second piece of information, which I'm going to highlight in red, is the half-life. And the half-life tells me we end with half of our stuff and we begin with all of our stuff. So we begin with one and we end with a half. And the 1599 is the time it takes to get there. So we're going to do some information with this. So one of the next things that we're asked to do is we're asked to find this initial quantity. This initial quantity is my C value. So I've got to figure out how to solve for C. And the last thing it's going to ask, after we have our equation, can you figure out how much it has left after 10,000 years if after 1,000 years it has 1.5? Okay, so I'm going to start with my equation y equals CE to the KT power. And now I'm going to put in my half-life information. That's what I'm dealing with first. I know I end with a half of whatever it was that I was starting with, isotope Ra260 or 226. That E, the K I don't know, and the T is going to be 1599. Okay, so the only variable that's left is the K. I've got to figure out how to get a K out of this, and I'm hoping that you remember your pre-calc and some of the things that we've been talking about. I can introduce a natural log. And when I introduce a natural log on each side, I get the natural log of 1/2 equals, remember, all of the stuff from the exponent comes down, the K times the 1599, and then I'd have the natural log of E. And you guys all remember that the natural log of E is same as the number 1. So now all I need to do is the natural log of 1/2 divided by the 1599 is going to be my K value. And I am going to leave it in this form because this is exact form. So now I have my new equation. It has become y equals CE. My K value is the natural log of 1/2 divided by 1599, and then my T value is still there. Hey, I got one of the variables gone, but I still need to solve for E, or for C. So I look at some other information. And now look at this. When I know my time is 10,000 or 1,000 years, I know my end value is going to be 1.5 grams. So I'm going to plug that stuff in. I know I'm left with 1.5. I have no idea what that C value was. E is still raised to that natural log of 1/2 divided by 1599. And if you give me a decimal here, if you round incorrectly or if you don't round far enough out, it will significantly change the answer. So we've got to leave it in exact form. And then my time was 1,000 years. I can now figure this out by doing a little math. I need to get the C by itself. So I'm going to divide by all of this E stuff. And I get 1.5 is being divided by E raised to my natural log of 1/2 divided by 1599 times 1,000. Grab your calculators, work that out. That's your C value. And in calc, we take it to 3 decimal places. And yeah, we could leave this exact, but it's going to get a little messy. And it turns out to be 2.313 is my C value. So now my equation has evolved to y equal 2.313 e raised to the natural log of 1/2 divided by 1599, and that has a t tacked on behind it. So now, finally, to find this last question, y is going to equal 2.313 e raised to the natural log of 1/2 over 1599 times 10,000. Grab my calculator again, plug it in, and I should come up with 0.030, and that would be grams. So I figured out my y value, I figured out my c value, and those were the things that they were after. No calculus involved, just a bunch of algebra. So if you want, try this next one by yourself. You can pause the machine now, or you can keep listening. So again, here is my isotope, carbon-14. That's the name of it, not going to do anything for me. My half-life information tells me 1/2 of it is left. That's my end. When I begin with 1, and it tells me the time that it's going to do that in is 57:15. Initial quantity, hey, guess what? This is my C value. I am lucky enough to know that C value. And now the question is, can I figure out how much is left after 1,000 years and how much is left after 10,000? Okay, so we are going to solve this for K. And when I solve this for K, I've got my equation y equals CE to the KT power. And obviously, the half-life is what we're going to plug in first. And 1/2 of it's left equals the beginning of 1, E raised to the K times 5,715. That K is stuck in the natural log, so I introduce an ln on each side, and I get the natural log of 1/2 is going to equal, remember the exponent comes down, K times the 5,715 times the natural log of E, which we all know the natural log of E is 1. So my K value is the natural log of 1/2 divided by the 57,715, I can't say it, is my K value. So as we evolve, I now know the equation is y equals, ooh, can I just plug in the C value of 5? Got that. E raised to the natural log of 1/2 divide it by 5,715 times t. Okay, so now for second and third part of the equation, all I'm going to do is plug in the t. Y would equal 5e raised to the natural log of 1/2 divided by that 5,715. And again, you want to leave that k value in exact form, because if you round it, you will be significantly off, and I'll mark it wrong. And when I do that, I grab my calculator, plug it in. It should come out to be 4.429 grams. Same idea here, but plug in 10,000. I wish you guys had to write on this once. You'd see how hard it is. And your Y value should turn out to be 1.486 grams. Okay, so we got one page left. And on this next page, it gives us the continuous interest formula. Oh no, it's not a C value anymore. It has P. Well, guess what? I'm going to tell you your A value is your N value, just like it was on the front. The P value is your beginning value, just like it was on the front. The R is going to be the rate that you have interest at, and T is going to equal time. Okay, so you guys, this is the same as Y equals CE to the KT power. This is the PERT formula, A equals, and this is continuous compound interest. Okay, so if you invest $18,000, that's what I begin with, at a rate, remember you got to change that decimally, 0.055. How much will it take to double your money? Double my money means if I start with 1,800, would I end with 36? Or if I start with 18,000, would I end with 36,000? So for this first one, I'm doing it in black. I have my equation. A equals PE to the RT power. So I'm going to end with 36,000 because that's my doubling amount. I'm starting with 18,000. E is raised to the rate of 0.055, and I'm solving for t. Hey, that t is stuck in that exponent. But before I introduce a natural log, I have got to get that e by itself. So I am dividing by 18,000, and I'm left with 2 equals e raised to the 0.055t. I now introduce a natural log on each side, and I get the natural log of 2 equals 0.055t, natural log of e, and you guys know the natural log of e is 1. So my time, how much time would it take to double my money? Whatever the natural log of 2 is, divide it by 0.055 on my calculator, and when I work that out, it should come out to be 12.602 years. Okay, so the second part of the equation said, what will the amount be after 10 years? After 10 years, A equals PE to the RT power. I'm looking for the A value, so A is still going to be in my equation. I still start with 18,000. E raised to the same rate of 0.055, and my time is 10. Grab your calculator, work that out. It should be worth $31,198.55. Again, no calculus, just pre-calc stuff. Okay, try this next one by yourself and then come back and check the video. So, stop. Okay, welcome back. So, if you won $1 million, that's what I want to end with. Save for retirement. How much would you invest now? So I'm looking for my P value, in an account paying 6.5.065 for 40 years. There's my T. Okay, so I'm going to have 1,000, well, I'm sorry, 1,000,000, 1, 2, 3, 4, 5, got it, equals, I don't know my P, my E is raised to the 0.065, and my time is 40 years. Okay, get P by itself, 1,000,000, gotta write out all the zeros, divide it by E, raised to the 0.065 times 40 power, equals P. Grab your calculator, work it out. It should be, I need to invest $74,273.57. One more. Okay, bacteria. The number of bacteria in a culture grow increasingly by the law of exponential growth. Exponential growth, that's the equation from the front, y equals CE raised to the KT power. There is 125 bacteria after 2 hours. 2 hours is a time, and this many bacteria after 4 hours. So, first thing it says we need to do is find our C value. That is my initial population. Okay, so let's know what we did have. This is an N value. This is a time. So if I take my equation, y equals CE to the KT power, I know I'm ending with 125. I don't know what I'm beginning with, so it stays CE. The K value, don't have any idea of what the K value is, and the T would be 2. Uh-oh. That doesn't help me a ton, does it? But they gave me a second one, and with that second one, I have 350 ending values equals CE to the K times 4 would be my time value. So, I might have something going on here. That's the information that they gave me. I'm not exactly sure what to do, but I'm going to get the C by itself. 125 divided by E raised to the 2K power, I like the K at the end, equals C. And 350 divided by E to the 4K power equals C. Very interesting. C, could I set those two things equal to each other? Of course I could. 125 divided by E to the 2K would equal 350 raised to E to the 4K. So now I'm going to cross multiply, and when I cross multiply, I end up with 350e raised to the 2k equals 125e raised to the 4k. And as I kind of look at that stuff, I'm looking, I'm going to divide this by 125. And I'm going to divide this by e to the 2k and e to the 2k. And by doing that, I'm left with, so I've got 350 over 125 equals e to the 4k over e to the 2k, which now, lets me simplify this to 35 over 125 simplifies to 14 over 5. And remember when we have these, we can subtract their exponents if their bases are the same. That's the same as e to the 2k. Oh, I got rid of one of those e's, so now I could introduce a natural log. And the natural log of 14 over 5 is going to equal 2k the natural log of E, which we know is the number 1. My K value turns out to be the natural log of 14 over 5 divided by 2. Okay, so coming back to solve for my C value, and notice I'm finding my C, write the exponential growth model for it, let T be the hours, use the model to determine after 8 hours. We'll figure that out. And then after how many hours would 25,000 be in there, we will work all of that stuff out. So I've got my K value. So now if I come back to either one of these starting ones, 125 would equal CE raised to the natural log of 14 over 5 divided by, ooh, that is so tiny. Sorry about that. Let me try to erase this so you guys can see it a little better. This is 125 equals CE raised to the natural log of 14 over 5 divided by 2 times my time value of 2. Now, to get this C by itself, I'm going to take 125 and divide it by E raised to the natural log of 14 over 5 divided by 2 times 2. And that's going to be my C value. And when I figure out that C value, it turns out to be 444.641. That was a lot of work. Okay, so now my equation is y equals 44.641 E raised to the natural log of 14 over 5 divided by 2 times t. Okay, so I've got part A done. I've got part B done. I wrote the equation. Going on to part C after 8 hours. So I'm just going to plug in an 8 here. Y would equal 44.641 E raised to the natural log of 14 over 5 divided by 2 times 8. Plug that into your calculator. Your Y value should equal, I can't find my calculation, so I'm going to pause this for a second. Okay, so I'm sorry, finishing this up, I just needed to put that into the calculator, and that should turn out to be 2,743.896. For part D, I'm kind of out of space, but this would be my, how many hours will it take? This would be my ending value, so I'd put that in for my Y value, and then I'd just solve for T by introducing my natural logs of E. You guys should be able to do this, so good luck. I will be back tomorrow, and we can talk about this, and remember tomorrow we start to get ready to review for this chapter. So